So, Linux and its microcomputer predecessors pre-1996. Oh, I have to put the USB plug into the wand, or so it's not going to work. Sorry. Technology, right? All right, so this is a general talk. Here's some players from our 20th century journey, if you haven't met them. I think everybody here has seen them before, but it's all right. Let's warm up the time machine. We all use Linux, even if we don't know it. When you see a machine reboot at a grocery store, it's like, oh, hey, there's a penguin again. Linux has arguably become the most ubiquitous operating system. But how did that happen? Well, here's a story that's usually given. It's an undergrad posted about his hobby project, and a bunch of people helped out. Heard that one. But wait, a college kid with a hobby project started a computer project by posting? That's absurd. I don't believe that. What about these other things? They're only the Unixes ones. Oberon by Pascal's Nicholas Wirth is from 1987, and there were many others that didn't make the deck. But these did. Here's various other commercial efforts. Some of these are complete systems, others are kernels. The lines between are the first and last release of them. Linux wasn't shouting out from the wilderness. There was a vibrant PC Unix ecosystem that predated him. Products such as Unix and Coherent were hot stuff at one time, but now they are the works of Ozymandias. Look on the timeline, ye mighty, and despair. That's because this guy, Genghis Khan, the Unix War. There's only one commercial Unix without hardware still attached to it, still around. Xinuos UnixWare 7 Definitive 2018, which last release was actually in 2017, and that's it, instead of than dial-up. But Mr. McKenzie, there's more to the story. What about the BSD lawsuit? Well, what about it? The first BSD was released in 1978, but for our story, we'll only need two names, a husband and wife team, Bill and Lynn Gillitz. Why didn't that win the Unix war? This is usually given, but it's not persuasive. BSD is much older, and in an interview with Bill Gillitz in 1994, he said he started working on 386 BSD in 1986, even though only Net 1 and Net 2 were released in that interim. Also, there were 5 lawsuits that held up Linux in court for over a decade. Did that really affect its development? Okay, let's assume there was a 2-year-hold in BSD. Then we should go over to, say, Usenet and see a fair amount of silence during that time. But in fact, we did not. This is just over 2 days. It was lively and vibrant. There's no evidence of any chilling effect. The highlighted post is an update of the lawsuit amidst a bunch of articles talking about progress and bugs. Mapping out the velocity of Usenet articles and BSD groups to look for change correlated with the court case activities showed nothing of interest. However, there were a number of articles across Usenet with titles like Linux or 386 BSD where people compare them. Many include minutiae such as specific hardware, but none talk about the lawsuit. Also, there's a first mover advantage theory where people write history from the first successful implementation and forget everything that came before. There were digital currencies before Bitcoin, MP3 players before iPod, and social media before Facebook. Linux's timing was favorable, but there's more to that than that. So we have to reject the hypothesis that BSD was held back because there's no contemporaneous evidence. Besides, NetBSD went out in '93, FreeBSD in June. They already had things like networking. The first installable Linux was MCC Interim in February '92. It's really not that far apart. Tell me how wrong I am, go to the URL and denounce me at your leisure. But just to show you that I'm a big fan, here's a FreeBSD shirt from the 90s. So I don't hate FreeBSD. Okay, I've been with it for a long time. Oh, I didn't go over the first slide. I skipped that one. Anyway, the most important one, I skipped. This, sorry. I really care about accuracy. And so I made a page for you to correct any of my mistakes over here. It has all the slides. It has all of my history. It has about 24 YouTube videos of me preparing this thing. It has all of the assets, and it has the script. And it has a way for you to comment, and if you have any questions or concerns, and if you want to have about 500 gigabytes of archives that I can make available as well. So, sorry about that. I don't know how I skipped that one. I've only done 22 test runs of this. Do you think I would have not fucked that up? All right. My apologies. We are at number 14. My apologies. Regardless, Linux has become a few orders of magnitude more prevalent than BSD and killed commercial Unix. How? There's two possibilities, the great man theory and the social history. The second is harder. Let's try the first. It looks easy. It says some glorious thing happened, but you can't do it because you don't have the right genes. Unfortunately, this isn't useful unless you enjoy sulking about the things you consider flops. But you're all rock stars, right? I hope. Okay, so what about the second one? Using syllogisms, we are mere mortals. Mere mortals did this, therefore we can do this. But only if we know how. The first is a much shorter speech, a Carlyle-style hero worship about how great men should rule and others should revere them, a gushing mystical biopic. However, we've got a much harder job. And to do it, we need defendable and falsifiable hypotheses. So, here's some more terms in case you didn't know these things. I don't know how, this is general talk. You all look pretty technical, but anyway, let's go on. Perhaps Linux was the second act of the personal computer revolution. Personal software and personal hardware. If the center will not hold, things fall apart, and mere anarchy is loose upon a world, we might as well make it productive and get some nice software out of it. Maybe if Unix needed a pool of hackers to build it on cheap computers with a robust communication network and avoid bad actors taking advantage of their generosity. Maybe. There's also the maybe nots, that falsifiable thing I talked about. Number one, Unix was thought to be really complicated. Actually, it was seen to be quite elegant and simple. The Unix source license was $200,000 in the 1980s, so of course it was complicated and magical, but that was just marketing. Even 386 BSD, 20 years into Unix, was done by the Dolitzes, a husband and wife team, just two people. Number two, community-based programs were thought impossible. There's an organization called Share who came up with a Share operating system in the late 1950s, which was community developed. Share was eventually structured closer to BIOS Cooperative. To see how it worked around the birth of Unix, let's go to Computer World 1968. During the past 4 months, Share has been working with IBM to define changes needed by users. When the company responded, 12 out of 13 requests has been turned down. Well, IBM, look at what happens to you when you ignore your users. Oh yeah, Share was Los Angeles-based, so LA pride. Speaking of things that happened over 40 years ago, ancient history. Although Unix started in 1969, the first paper went out 5 years later. Here's 4 principles extracted from it that will be useful for our journey. Leverage, don't invent. Doing beats planning. Needs, not desires. Use early, use often. Although each one of these may have its flaws. Together they form a cohesion, even a synergy, if you will. Unix was designed for a dead class of computers called mini-computers. They were about an order of magnitude or 2, cheaper than mainframes and also less capable. Well, at first. People wanted to solve their tasks on cheaper machines because that's all they had access to. Roughly every decade, a new lower-priced computer class forms based on a new programming platform, network, and interface, resulting in new usage and a new industry. That's Bell's Law. It's from 1972. As mini-computers came on the market and became more powerful, Unix was there to leverage them to service people's needs. These new machines provide a new context for new software. These needs are only meant as examples. The point is that the velocity of computer progress went faster than people's needs. Apparently, computer performance increased as a square of the cost of transistors. A square of the cost and transistors per chip doubled every 18 months. Those are called Gauss's law and Moore's law. Together, it meant the industry eventually ate itself through a multi-decade-long digestion. However, when new things come in, the people who get there early don't get there easy. It's okay, though. Some of us are crazy and prefer it. AT&T was under many legal obligations, and because of that, Unix was initially distributed as if it came out of the back of an unmarked white van. The mantra was part of the presentation deck for early Linux, saying, "You're on your own." Think of the adventure. Think of the excitement. But who are you catering to with such a message? Well, where will their behavior guide things? It's not about welcoming everyone doing anything. With any of these efforts, you have to ask yourself who you're bringing to the door and what kind of behavior you're expecting. That's what separates a library from a soccer field. For example, Linux, September 1992. Minix is good for education, coherent for simpler home use, Linux for hacking, and 386 for people who want 386 BSD for people who want the real McCoy. Or Linux, a year earlier. You also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386s with access to Minix. Maintaining focus is about intentionally, not incidentally, but actually intentionally choosing what to ignore. You have to be a clear signal amongst a noisy world. Because you had to know what you were doing, Unix was initially introduced through engineering and technical people and not through the conventional decision makers. But it worked. And by the 80s, Unix was mainstream. The problems. As both the consumers and producers of Unix multiplied, the suppliers differentiated themselves, succumbing to the trappings of usual competitive markets by enclosing the commons, trying to take ownership of groups and commonly held things by setting up barriers, thus locking them in and growing their base by trying to be special, which led to fragmentation. Unix had infected everything from workstations to mainframes. Unisys, one of the mainframe makers, had an article in September 1987 issue of Computer World predicting a tripling of Unix sales in that year alone. The problem with the infighting goes back to the chart with the various blobs about computer classes. The threat is almost always coming from below. In this case, it was Microsoft and microcomputers, and not Nixtor Cynix on an NS32000 versus clicks on an Intergraph Interpro. In 1985, Microsoft argued that their Xenix Unix, which had an install base of 100,000, would be a multi-user version of DOS. In 87, they said they didn't see it competing with their plans for OS/2, which at the time was seen as a successor to Windows 1.0, LOL. Things changed, specifically that December, with the introduction of Windows 2.0, and later with Windows for Workgroups and NT. That was the real threat. Anyways, Xenix required 12 360K floppies, which is seen as bonkers. I don't know how young people would be, but you're all kind of old. In case you're kind of young, 12 360K floppies. You'd have to put these in manually. You're kind of young. You can look at that. A 32 gigabyte micro SD card is about 93,000 floppies, 190 meters stacked end to end. That's like a 2.5-minute walk. All that storage is now on the size of your thumbnail. It costs as much as a taco on the west side. Anyway, software distribution used to suck. Speaking of Microsoft, that punch taped up there is how they distributed BASIC for the Altair in the 1970s. It took about 20 minutes to load, and it wasn't stored on disk because the Altair didn't have one. Just keep the computer on if you want to use the software. The lower right is called a type-in program. Software is distributed like this as multiple pages of hexadecimal. No, really, this is MLX format. They published listings like this every month for years. You typed it in. There was no electronic reader. There's some basic code on the first page, and it's not pretty either. The QR code is this game running on an emulator in your browser. You can scan it and just tap it on your phone. No typing required. Anyone want to scan it? You can scan it, give it a try if you want to. You could only use the software that you have access to. There were also software user groups which were convenient for the 1 to 20 people who lived near one. People want to, you can do it. It brings up a Commodore emulator, and then you can just play it. And imagine back then, if you wanted to actually play that game, you'd have to sit and type in all of these hex codes. It'd take hours, right? And now it's just a few seconds. So much easier. But for most, the software meant retail, mail order, or copying a floppy from a friend. The bottom two methods have consumer overhead. For dial-up, you usually had to pay an expensive phone bill, and for internet, you probably didn't have it. 2400 BPS access to Genie in 1989, for instance, was $42 an hour, and that's how long it takes to get a megabyte over 2400 BPS. This means most people were only exposed to the top 3 groups, and it was difficult for smaller developers and non-commercial ones to get their software to the masses. Paraphrasing Marketing High Technologies by Bill Davidow in 1986. It's not a product without a distribution channel, or in Linux's case, a distribution. The technology may have the potential to address the needs of many, but without specialists, redistributors, to put it in the hands of those customers, it will not succeed. Products are sold through distribution, not to distribution. Let's jump forward to the why Linux question. Here for a bit, with its diagrams up, Linux has high accessibility of the install media. March 1993, Unix World listed FTP repos, BBS numbers, and companies you can mail order Linux from. Later, you could find Linux at coffee shops, libraries, and attached to magazines at the grocery store. Filling up a CD with Linux distro and cribbing some how-tos was cheap content for a magazine who just wanted to get an issue out. But let's go back to the problems. Depending on the distribution channel, updates had logistic complexity, especially when considering updates from outsiders. For instance, if you wanted to update a retail copy of Lotus 123 and have your changes appear at the shelf of Circuit City, you'd probably have to do it yourself and get arrested. It would have been fun, though. Once there were online networks with storage and communication necessary to unlock the multiplayer online mode for the software development game, a new way to write software was created. Yaki Benklorn described this as commons-based peer production in his book, The Wealth of Networks. Let's go to Linus, 1991. I've enjoyed doing this, and somebody might enjoy looking at it and even modifying it for their own needs. It's still small enough to understand, and I'm looking forward to any comments you might have. I'd like to hear from you so I can add your software to the system. Adding Minix things to Linux is fine, but how do contributions and updates work? Unless you can answer these questions clearly, progress will be slow, infrequent, and inefficient. Everyone has to agree on the terms and feel welcome, otherwise they become petty and don't come around here no more. So GNU made a Rooseveltian list of 4 software freedoms to define free software, but it's not just license. It's organization plus license. For our purposes, we're going to talk about horizontalizing software development, what's labeled adoptive in this chart. Essentially, how easy is it for modifications to become integrated and in the same distribution channels, and other people to become a distributor or to share your product? You need a legal structure and organizational structure that affords this, an open shop that permits anyone to come in. Eric Raymond spoke to this in the Cathedral and Bazaar. In the Cathedral model, which is tall, source code is available, but development is restricted to an exclusive group. Contrast this with the bizarre model, which is flat, in which code is developed over the internet in view of the public. The vertical lines here, from permissive to restrictive, is a general continuum. Public domain is seen as too permissive in the eyes of GNU because you can relicense and reprivatize things. I've also read that copyleft and GPL are different from each other, but I never went to law school. If you zoom in, you'll see non-computer things. Let's go over a few. Bottom right is facts. People ought to be really hesitant to modify facts, and they're public domain. Above that, you have most religions. Anyone can preach the good word and start a congregation, but at least in principle, the texts are sacred. As we go up, we get jokes, recipes, human language. At the top is folklore, which changes readily. As you move to the left of public domain, you get Wikipedia, which anyone can edit. On the restrictive adoptive side of social media, anyone can contribute, but the platforms retain a bunch of rights. Commercial software is down in the hesitant restrictive camp down here. The pink stuff is all Linux related, which if you're colorblind, it's this person right here. Minix is actually down next to freeware and GCC in the hesitant category because below the pool label Unixes. Except for social media and Wikipedia, all of this is early 1980s and not 2024 accurate. And so some of these softwares, they change terms over time. But this is a history talk, so we're talking about early 90s. Speaking of the past, let's go to the introduction of Minix. In 1986, commons-based peer production wasn't feasible. People didn't have the internet in their pocket. Because of the prohibitive logistics around software distribution updates, and especially customer-initiated, Minix could only be a cathedral. Also, it was a product of Prentice Hall, who wanted to sell textbooks and instruction material for Andy Tannenbaum. So here's the relevant part of the announcement. It's not public domain. However, the publisher does not object to people making copies for friends. That's SneakerNet. If you want to sell it, which is the two categories above SneakerNet, retail and mail order, you need permission. In his book, you will find a postcard that you can use to order the software. That's our mail order again. And he says he doesn't want to copy a bunch of floppies, as in do SneakerNet. As you can see, these distribution channels are all throughout all of this old stuff. So now Minix was adjacent to GCC. As I said before, what's up with that? GNU was also cathedral. Here's an example from an early GNU bulletin, 1987. We can see it listing out different distribution channels, again, same pattern, as they solicited funds to pay programmers to write more software, like a software engineering firm, GANs. Here it is. They played a second role as a provider of copyleft and eventually software under the GPL, which came out a few years later. GPL was 89, this is 87. Every bulletin has a growing list of software by others that you can order. You could get Net2 BSD and then BSD 4.4 Lite from them until 1995 because Linux came from below and GNU got disrupted like everybody else. Then GNU started backing a Linux distribution, which ended up breaking up with them, called Debian. As far as distributing free stuff goes, there's precedents, such as this one from 1976, trying to be a repository for public domain software. This from smaller producers, such as Code Publishing's Dr. Dobbs Journal. Some assembly programs ran over 40 pages long in that publication that you, of course, were expected to type in yourself. So people were looking for a more reasonable solution that didn't cost as much, but not all the pieces were there yet. All of these things required labored coordination and resources. How we instrument those means some things get better faster. Ideas are bizarre even when their implementations are cathedrals. For instance, there are many graphical desktop computers, even though each one was a proprietary restricted project. The superstructure of desktop computers operated in the adoptive space. Pretend we have a concept of a free operating system. We may not get all the parts right the first time, but the Platonic ideal exists. Well, kind of. It's as much a contemporaneous invention of anything else as a pale true thought suspended in our life stream. We can go back to Vannevar Bush's Memics article, as we may think, in the Atlantic from that was the wrong button. In 1945, to see the spirit of what we now call many things. Unlike products, Platonic ideals are collective projects owned by nobody. They're permissive and adoptive and not static abstractions divorced from human influence. They're ideas manifested from context. The map is not the territory, and in our industry, we are tasked with creating both through pure thought stuff. What a responsibility. We better get organized. This is about the complexities of building software, not about electing people, so don't worry about that. You may have heard that commercial software began when Bill Gates' open letter to computer hobbyists in 1976, where he denounced SneakerNet distribution of Altair Basic because he didn't get paid for each of the copies. I'm sure people have heard that. I thought that was the beginning. That's not really where commercial software began. In the mid-50s, software was in-house, coupled with hardware, or contract-based, as you can see from this 1959 ad from punch card data processing. But the version of commercial software that has products for a computer you already own has existed since at least 1960. No, really. This is another falsifiable thing. Bruce Perrin's chapter Open Source, Stephen Levy and Hackers, they allude to a Garden of Eden in the past from which we have fallen where all software is free. Really? Well, no. Here, 1966, claiming commercial software was a $100 million industry. And then in 69, 11 companies worth at least $100 million got together to form a trade group. Hardware vendors bundled software to lock in their customers like Microsoft did with Internet Explorer. It was as free as Windows is on a retail laptop. People were trying to DRM and patent software back in the 60s, and more than one succeeded. Maybe there was some idyllic Valhalla in a bubble known as the MIT Artificial Intelligence Lab, but the real world was up to the same tricks they are now. Anyway, software unbundling happened in 1968 and 69, vendor by vendor, and Unix arose from this primordial soup as one of the oldest non-mainframe software that is still recognizable today. Recognizable because the family tree looks like a European dynasty. This Unix timeline covers a few years in the late 80s. Zooming in, you'd see Minix, MIT Trix, NOS, Mach, Xenix from the House of Free Software, AT&T, or the Kingdom of Microsoft. I'm still not a lawyer, but this is really confusing. Not only did the source and binary have different terms, but sometimes only certain organizations had access to them. For instance, if you're an educational organization with a pre-existing AT&T license, then you had access to BSD, I think. So a version might have multiple parents, each with a different sheet. It's legal Habsburg. So that's why a few slides ago, there's a puddle to label Unixes. Each of the Unix term, even the Unix term itself is a confusing mess. Raise your hand if you still think it's copyrighted by AT&T. Be honest. Anybody still think Unix is a copyright of AT&T? Okay, we have a few people here. All right, you're all very smart. But that's a no. 31 years ago, AT&T sold Unix System Laboratories to Novell, who then donated the Unix copyright to the X-Open Consortium, which merged with OSF and became the Open Group, which is now a standards organization. Some Linuxes have gone through that process, so Linux is now a Unix. Really? You just finding out right now? It's absurd. We need something with clean, documented history, clear license, and easy answers to all of these problems. So Linux and effectively all modern open source projects have this solved. All development is open. The history is well archived, and the OSI-approved license solves this family tree problems. The structure that's now ubiquitous is one of Linux's major contributions, and we don't hold it up as that. Modern open source software is really due to that. Also, let's talk about the internal politics of building software. In the abstract penguin slide, we covered the outside aspirational curve, where things take decades and opinions are strong and many. Things like paradigmatic ways of doing open source software development took 20 years to dominate because the longevity and applicability of the more abstract solution is on the same time frame as their implementation. But within that exists lower level Maslowian motivations. And keeping things there makes them more actionable. Let's say your network card is not sending out packets. We can say this bug is known, agreed upon, and demonstrable. So although it may not be easy, the labor path is traversable. A new network card comes out. You need it to work on Linux. That's a need. You can demonstrate and come to an agreement on what that would look like. Pretend you wanted a network card to do something it wasn't designed to do. That's harder to demonstrate and agreed upon. So we're in the desires category. To get it actionable, you need to pull the desire into the lower curve so its development cycle can encompass it. It's worth noting the Tannenbaum-Torvalds debate from 1992 illustrates this. Tannenbaum chastised Torvalds' approach because it wasn't a microkernel, and Linux was exclusive to 386. Really, Linux was in these lower curves, and Tannenbaum was trying to pull it up to the higher curves where things move far slower. That's where all the hot research always is, people trying to make these higher-level concepts more real. GNU heard of the microkernel approach. Stallman claimed in the early 2000s that's why it was taking so long and wasn't very stable. The higher-level curves are unlikely to succeed unless except as superstructures of the lower-level functions in the same way their asymmetric approach to Platonic ideals happens in the back of incrementally more appropriate implementations, which is why you can snake a line from 1950s IBM share organization to GitHub. Through that process of clarifying the aspirations, they get moved to the concrete as they become material needs and bug problems. The clarity of the present stands on both the triumph and the wreckage of the past. For example, the Mach 3 microkernel led to Pink, NextStep, Workplace OS, Taligent, and eventually XNU, which is part monolithic and now the basis for Mac OS. To get there, that curve burned over a decade through multiple companies and billions of dollars. Also, the OSF group I mentioned before had a Mach BSD hybrid named OSF1. Apple was going to use it in alliance with IBM, but that got canceled. It went on to become True64, whose last major release was in 2000, 24 years ago, to add IPv6 support. How's that transition going? As a cynic, I tend to know the cost of everything and the value of nothing. Oh, speaking of costs, the prices. Here's both an article and an advertisement from May 1990. Sun says they have a cheap $6,700 computer, but here's a PC at about 1/10 the cost, which is fine if you can do some of the same things. Historically, that answer had been no, but referring back to the chart with needs in computing classes, this dynamic was likely to change soon, especially since the 386 had technical features which made running Unix-style operating systems more practical. Let's talk about the price of Linux. 0, right? No. You were paying hourly for dial-up internet access. But between 1989 and 94, that price dropped 90%, and the speed quadrupled, which meant $100 will now cost you $250. You could also get Linux on floppies or CDs, initially priced like cheap commercial Unix. SLS was 100 and nascent was 90, but GPL allowed anyone to distribute, so these prices collapsed quickly. But that's not the only kind of price there is. There's also the price of time. This is a conceptual, not a quantitative graph. Essentially, Windows is the easiest, but let's say you wanted to convert a bunch of files, sort the contents, pick a field, extract values, do some operation on them. These things get hard quickly. Early on, the BSDs were a pain to set up, but they had networking before Linux. They were more professional. However, there were fewer people working on them who tended to be more experienced, so they were busy and expensive. Linux was mostly students, which are famously cheap. Linux was also heavily hobbyist-oriented, which usually meant the systems were more hackable. The other Unixes presumed you had something important to do. The more difficult and time-consuming it is for a customer to use an information system, the less likely it will be that they will use that information system. That's Calvin Morris from 1959. As the complexity of the problems became more intractable, the approachability of the lower levels and internals of the system became increasingly important because people tend to use the most convenient method in the least exacting mode available and stop as soon as minimally acceptable results are found. That's the principle of least effort, and it's also how hacking works. Hackers tend to build worlds where everything is possible, but nothing of interest is easy. Alan Perlis called this the turning tar pit in 1982. Pulling yourself out of it from a capable to a usable system requires some engine to push it forward. Commons-based peer production can also be seen as prosumer, a producer and a consumer put together. It's used in social media where you're consuming other consumers' productions. Here, our engine is problem-solution integration, which keeps us in the bugs-needs development cycle. With the bizarre method of development, the changes reflect back quickly, which means that new users have fewer problems with their different hardware, so that for other people with, say, your network card, it will just work. But where do you find the people to do that? Well, you have to build armies, of course. Large networks are important. Their utility scales quickly with the size of the network because the combinations of groups grow faster than the utility of the groups that join. That's Reed's law. For example, we start using Linux. You have a network card that doesn't work. You can now join the subgroup of people, becoming a we that needs this card to work. This only becomes an engine if we have the right people to complete the cycle we talked about. The first levels here are the enthusiast developers and bug fixers, followed by the curious hobbyists. Then the business needs, and finally, people that can't have things fail. Arguably, one of the failings of the early BSDs is that they were too lopsided in the upper steps and couldn't get the virtual cycle moving with enough velocity. Analyzing email addresses of about 2.5 million Usenet posts over a 2-year period, there were almost always more commercial emails for BSD and more educational ones for Linux. So even though their general trend was ascending the staircase, Linux had more torque from the bottom groups. I call this ACPI. Oh, come on, ACPI. I'm sorry about that, people. Your time is valuable. I call this Linux's revolutionary theory. The hacker vanguard forms a coalition with the personal computer proletariat, and the business-oriented bourgeoisie becomes interested, and finally, prohibitive, assiduous aristocracy is able to use it. There's one last type of price, expertise. You could assign a utility function roughly as the capability is divided by the effort required. So we've gone over 3 types of prices here, money, time, and expertise. And we have those constants here, and then we have utility is basically software capabilities divided by effort demanded. For example, where am I doing? Sometimes both capabilities and efforts increase over time. Blender, for instance, is highly capable software, but takes a lot of expertise to use effectively. Many mobile apps, on the other hand, actually remove power features over time to make the product require less effort while making it less capable. Still others, frameworks, for example, get Fred Brooks' second system, a new version that's harder to use and leads to inferior results, thus being the inversion of the graph and decreasing the utility of the product. But let's talk about these multiple arrows here. To get a larger user base, you need a diversity of capabilities requiring a diversity of efforts. Linux was able to achieve this by outsourcing the actual packaging of the OS through distributions. This is another insight about the bizarre software model. Since the entire structure is more flat and structural organization barriers are mostly removed, as markets naturally subdivide and form, they can be quickly and readily addressed. Because we're doing social history, let's use critical theory Marcuse's idea of de-radicalization. The dominant structures, say markets, subsume the novel. However, because in bazaars people can self-organize, they beat it to the punch and move faster than the market force, which is why open source decoupled structures are more dynamic and swift-footed than commercial approaches. Here's a chart from Innovator's Dilemma, describing different strategies that can be taken as technology gets better. You can push up market to higher end consumers, or you can stay with your existing customers. However, because of the horizontal development of Linux and the existence of distributions run by multiple organizations, it was able to do multiple strategies at once. Not only these, but any others that have been left out of this graph. So the packets, more P words. A few slides ago, we saw how Linux has a horizontalist, bizarre approach to software internally. Let's look at the implications of this externally. This chart is taken from Andy Grove's 1985 text, Only the Paranoid Survive, describing how the industry moved from one-stop-shop verticals to a horizontal structure. If we put this in the aspirational space, this can be viewed as part of the same decoupling superstructure as what the mainframes were doing in the late 1960s. The premise of this transition was a book called The Coming Computer Industry Shakeout by Stephen McClellan in 1984. Quoting, "As software gains ascendancy, the key words will no longer be customization, specialization, and market niche. The new word will be integration. Systems integration will be the most sophisticated and difficult task computer companies will have to undertake." That quote, being 40 years old, gives us the privilege of seeing what happened. Essentially, 4 strategies were developed to tackle this problem. And so somebody pointed out that when I was doing a test run, that this one is here, that one is there, and that one is there, and that one is there. Anyway, so the first is to impose on a vertical by claiming you're the standard. But in practice, only one player can do that, so OS2 died. Well, not really, it's ECOS, but nobody uses it. Apple took a different route by being its own vertical, while Linux had to push out the wheel out of the tar pit and need enough people to do it. Luckily, timing was on its side. When the internet was mostly accessed at universities, September annually brought in a flood of new people that had to be coached. As residential internet grew, the old guard termed 1993 as the eternal September, the beginning of the mainstreaming of internet access. For this to happen, cheap ISPs and web servers needed to exist quickly to support users, and Linux was there to provide. It's important to note, though, that Linux was prima facie hobbyist and personal use oriented at the time. Even though Linux Journal, we had one of the original writers here earlier, has articles in 1994 about it as web servers and running ISPs. Contemporary texts such as Linux Getting Started, Unleashing the Workstation in Your PC, or Plug and Play Linux went the lower 2 steps of our staircase, hobbies and personal. The early Slackware, MCC, and SLS distros from the time didn't include web servers or tools to run a business. The first people in new use cases don't get there with clean off-the-shelf solutions. They play the scout role, clearing the road for the army to roll in, which is why the web server book in 1985 now includes Linux. That's how that happened. Another benefactor of the eternal September is attributed to Linus's law: given enough eyeballs, all books are shallow. Let's look at the various eyeballs. The first term slide, which none of you probably read, claimed that Linux was mostly built by college students. Here's some evidence. After first releasing in October, Linux got some help, and in November, local help, sorry. And in November, it had contributions from Hong Kong, MIT, and University of Utah. In December, code came from Calgary and Berkeley, and then Colorado and Maryland students came in January. So far, everyone is under 25. As there became an increasingly pressing need for a solution like Linux to solve new problems. And that need has more or less persisted to this day. Apple is vertical, Microsoft is entitled, and Linux continues to climb stairs that have yet to be drawn. Here's a quote by Torvalds. "I think the timing was good. Even just a year earlier, I don't think it could have been done, and a year later, somebody else would have to do something similar." These 2 bottom charts show how Linux now dominates supercomputer and web server space. So how's everybody doing? Are you still awake? Yes, that's typed on this sheet, as is this. This is long, so let's have some fun. If there's a storefront named open source, what would be displayed on its windows? In fact, let's do some interactive theater and what looks like the Kekistan flag. We're a group of people in 1995 trying to bring free software to the masses. Our marketing director just told us about the marketing mix with the 4 Ps: product, price, place, and promotion. In order to have a figurehead for the free software movement, we need to find a piece of free software that qualifies these conditions. It should be easy to try, acquire, and understand. It should have a low price of time, money, and expertise. I appreciate all the suggestions so far. These are all excellent examples of free software. I especially like the elevator pitch for Emacs org mode. Before we settle on a whole project, I'm wondering if we've left anything out. Any suggestions from the audience? Anybody? Oh, yes, you, sir, the man that I've known for over a decade. That's a great idea. Maybe Linux can be the window dressing for the free software movement. Or how about this? I've got a better idea. Let's make an alt copyright pipeline. We have low-effort things for curious PC users to try. Then we gently tell them our community beliefs and encourage them to up their commitments. They'll become more familiar with projects which take effort and expertise, get involved, and become an advocate. Over time, they'll report bugs, help determine needs, and implement desires to move our aspirational project forward and make it more tangible. In order to do this, we must be a welcoming community by necessity, but also because we brought in the right people. We'll call it the Jeeples Temple. And that's how it happened. Oh, wait. How do we do it again? The perhaps. Geoffrey Moore made this graph in his work Crossing the Chasm in 1991. It proposed that commercial products mature, users with different behaviors and expectations come around. There's two holes in the graph, right here and here. The first group is people who are aspirational and have a high tolerance for impracticality, that's innovators. They are willing to go to the extra mile and make things work. Then there's a small hole, down right there. In the graph on the right with the electric car adoption in Norway, you can see that small slump, the first circle right here. The next group is enthusiastic about the possibilities but prefer lower effort, time, and expertise costs. That's the visionaries. Then there's a really big hole, which is the yellow one right here. The next group is a difficult one to reach. They're looking for a working product and don't want to be hassled with inconvenience. Many products don't make it there. So this is for commercial products. What about open source? I present Crossing the Open Source Chasm. The first group are passionate hackers trying to climb the aspirational curves and bring it down to the bugs and needs. If they can keep their passions going long enough and make sufficient progress, then perhaps the music makers will come around and help recruit more passionate people to enlarge that base. That's the first pipeline. If the engine between the passionate and the enthusiasts can be maintained in order to drive the problem solutions integration wheel out of the tar pit, the people can get pulled out of the trunk tar pit, and if the software capabilities divided by the software effort demanded yields enough utility ratio, then the pragmatists will become interested and the chasm is crossed. But in order to keep the pipeline but it's important to keep the pipeline well lubricated because you'll be facing new challenges and use cases and need a few of those new users to slide along the responsibility graph in order to grow the coalition as our law of division then takes hold. The clarity of the present stands on both the triumph and the wreckage of the past. Sometimes for a city to become great, it must first be destroyed so that a new generation can seize the dream and try to execute it better. Failure and passage of time unbinds us from commitments and gives us permission to kill our darlings and do a page one rewrite by naturally creating the space for us to try again, but only if we retain the liberty to do so. Here's a few historical examples. Anybody know what these are? Anybody know what this thing is? What is it?
Is it some sort of record player, Chris?
Anybody else? Radio? Oh, sir? It is. This is an early mechanical television. What about this one? It's the Cook and Wheatstone telegraph, a pre-Morse code telegraph technology. What about this? Yeah.
Maybe some sort of sound adjusting? Good audio?
It's much older than that, from the 1850s. It's an arithmometer. It's the first practical office calculator. Each of these devices have a different history, but they affected the same results. The aspirational curve eventually wasn't captured by a particular implementation. Sitting on the left of the curve, we'd like to intentionally accelerate the social technical processes, but it's a counterintuitive act. Otherwise, it'd be easy. Strong IP enforcements on strong visions diminish their chances of success. You must let go of that which you love the most. You may get the vision right, execution, timing, or team right, but probably not all at once. Facebook, iPhone, Google, Amazon. They're all iterative executions of larger ideas owned by nobody, and arguably failing on one or more of these fronts today. If you're working on a thing or have a dream and it's just you, then you're definitionally on the very left of the graph. You could argue for certain use cases, free software took over 20 years to cross the big chasm, and for others, desktop publishing, digital audio workstation, photo editing, or social media, the free software chasm is still not crossed. There needs to be a certain kind of affection for the people, their needs, desires, and aspirations, for these to eventually succeed, for, say, the GIMP to overtake Photoshop. The commitment to others with less responsibility is key, because that's how you get the new recruits. So whatever you're working on, it will take longer and manifest differently than what you thought. Don't have codependencies with it. It will foster resentment, anxiety, and low self-esteem. Really, you'll become susceptible to the great man theory. If something is dying, maybe that's the fire you need to rebuild things. Listen to the needs and desires of others, of the idea. So do one thing, do it well, work together, handle tech streams, because that's the universal interface. This is actually Unix philosophy by Peter Sallis, but I'm serious about it. Good software advice is also good people advice when building software. Let's go to Tracy Kadar, Solve a New Machine, 1981. Looking into the VAX, West had imagined he saw the diagram of DEC's corporate organization. He felt that VAX was too complicated. He did not like the system by which various parts of the machine communicated with each other. There was too much protocol involved. He decided the VAX embodied flaws in DEC's corporate organization. The machine expressed that phenomenally successful company's cautious bureaucratic style. Churchill said, "We shape the buildings and thereafter they shape us." However, our buildings are different because the programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air from air, creating by exertion of the imagination, or so says Fred Brooks. Regardless, wrecking balls for code are cheaper than those for concrete, so don't be afraid to use them. Here's another Unix philosophy. This time, think about it in terms of people. Make it easy to write, test, and run organizational efforts. Interactive use with humans instead of batch processing. Make do with smaller teams. You'll need all the engines to get over the chasms and move the projects forward. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Melvin Conway, Datamation, April 1967. We studied yesterday to create a better tomorrow. The future is ours to make. Well, perhaps. And that's it. Thank you. Appreciate it. That was 4 months of effort.